Week 5, lesson 2. All right, so this lesson is about something called discrete random variables. I'll let you read the definition in the box, and then there's an example that you can kind of take a look at down here. And then there's some new notation. All right, so big capital X is going to be the discrete variable, and something for you to recognize is that the sum, right, the sum of all the probabilities has to equal 1. That's what that notation means. Okay, so it's easiest if we just sort of jump in and do a problem. So the example here says that there are two four-sided dice are thrown. X is going to be the sum of the dice, and the big X is the discrete random variable. All right, so part 1, show all possible outcomes in a table. Meaning, I want to know if I throw two four-sided dice, right? 1, 2, 3, 4. What are all the possible things that can happen when I throw two of them? 1, 2, 3, 4. So I'm just organizing my information here, and I'm sorry this is kind of messy, but okay. Now notice here, this is really important. It says the sum of the dice. So if I toss a 1 and a 1, I get a sum of 2. I toss a 2 and a 1, I get a sum of 3. I'm going to pause while I fill this in. All right, so continuing, you can see that I've got the different sums there, okay? In red, I've got the sums. So down here, this represents the different sums, right? So what are the different sums that you're seeing in that table? Well, I see a sum of 2. I see sums of 3 and 4 and 5 and 6 and 7 and 8. Those are the only possible sums. And then this is the probability of each of those happening. So if you're looking, there are 16 possible outcomes, right? There's 4 by 4, 16 possible outcomes. One of those is a 2, and 2 of those is a 3, and 3 of those is a 4, etc. 4, 3, 2, and 8. Oh, I just wrote the wrong number. It should be a 16. Okay, now really, really important. These fractions right here, all of them, have to add up to be 1. Okay, so I'll let you double check that. Those fractions do add up to be 1. Okay, so let's take a look at the second page. Okay, so this one's just slightly different, right? Same concept, and you still see a probability distribution, but this one they give you like a formula. Okay, so there's sort of like a formula here for how to fill this down in at the bottom. So they give you the X values, 0, 1, 2, 3, and 4. And they kind of tell you where to plug it in, right, for the probabilities. So when I plug 0 in here, I end up with just 0. And when I plug 1 in for X, I get 1 over K. And when I plug 2 in, I get 4 over K. When I plug 3 in, I get 9 over K. When I plug 4 in, I get 16 over K. Okay, now notice the directions say find K. Well, if you remember just from, I don't know, maybe a minute ago, all of these numbers in this bottom row right here have to add up to be 1. So let's add those up. 1 over K plus 4 over K plus 9 over K plus 16 over K has to equal 1. So adding those up, I end up with 30 over K equals 1. In other words, K has to be 30. Okay, so now part 2, complete the probability distribution with actual values, meaning I don't want K's in there anymore. I now know what K is. So this is still going to be the same numbers on top, but down below, instead of having 1 over K, I'm going to have 1 over 30. And for 2, I'm going to have 4 over 30. And 9 over 30, and 16 over 30. Okay, let me scoot this up just a little. All right, so now it says, find the probability that X is less than or equal to 2. That would be these 3 probabilities all added up. 0 plus 1/30 plus 4/30 is 5/30 or 1/6. And then the mode is the one that occurs the most often, right? Again, these are probabilities. So like this thing, you're kind of it's never going to happen. This one has the highest probability. So the mode is that number right there.